Everyone, I'm Pranshu Pandey, a young data analyst at FinScoop. I'm excited to share how we can use linear algebra to understand and stabilize financial networks during economic turbulence. In this short talk, I'll walk you through a model that shows how shocks travel between banks and how we can reduce the risk of collapse. We started with a simple model representing four major banks: SBI, ICICI, HDFC, and Axis Bank. We used a 4 cross 4 symmetric matrix represents the strength of financial connection between them, like how much they rely on each other for lending and liquidity. Symmetric matrices like this shows mutual dependence, which is common in tightly linked financial systems. We analyze this matrix by calculating key properties like the rank, determinant, trace, and the null space. To understand the network's structure, we also solve the system A cross X is equal to B, which represents how resources or debts balance in the network. The solution confirmed that the system is solvable but sensitive to changes. Next, we performed eigenvector analysis. Why we did that? Because eigenvalues help us identify where the network is strong and where it's vulnerable. We found that smallest eigenvalue was around 0.38, which indicates a fragile direction. The largest eigenvalue, on the other hand, represents the dominant mode, how most market behavior evolves. To make sure our model is mathematically sound, we validated it using Cayley-Hamilton theorem, which confirms that the matrix behaves consistently with its own characteristic equation. This gave us confidence in the reliability of our simulations. We then simulated how the stock values of these banks would evolve over time under a market shock. We used matrix multiplication over time steps to see how the values of SBI, ICICI, HDFC, and Axis Bank changed. As you can see in the graph, banks like HDFC and ICICI showed larger drops, suggesting the higher sensitivity to shocks. So, what's the solution? Based on our analysis, I am proposing three target strategies to improve network stability. First, banks connected to the weakest eigenvalues like HDFC should maintain larger capital reserves. This acts as a cushion when this acts as a cushion when stocks hit and helps prevent a chain reaction. Second, during times of market turbulence, banks should temporarily reduce interbank transfer along risky channels. This is like turning down the volume when feedback starts. It prevents instability from growing. Third, we can use eigenvector analysis to rebalance portfolios. If a bank's investments are too aligned with the top two eigenvectors, it's overly exposed to market wide shocks. We should diversify along safer directions. In conclusion, by combining matrix modeling, eigenvalue analysis, and simulations, we have gained a deeper understanding of financial risks. This isn't just about numbers, it's about protecting investors, customers, and economy. With tools like this, we can build a financial system that's not only smarter but also stronger. Thank you everyone for watching. I hope this gave you a new perspective on how data science and linear algebra can play a powerful role in financial decision making. And I'm happy to answer your any sort of questions you have.